Lately, I have wondered what makes a plane fly, and why is it that some paper airplanes fly farther and longer than others. The width of the sheet used to build paper airplanes is a factor for the flight time of any paper airplane. In this experiment, I'll be able to identify the best width of a paper sheet to achieve the longest possible time of flight by changing its width to see how it affects the time of flight. I'll be testing 5 paper airplanes, each one with a different paper sheet width, launching them with a homemade paper airplane launcher and then measuring the time of flight of each paper airplane. That way, I'll establish the relation between the width of the paper sheet and the time of flight. In this experiment, I'll consider aerodynamics, which is basically the way air moves around things. I'll also consider the 4 forces of flight, which are weight, lift, drag, and thrust. Weight is a force that comes from gravity pulling down on objects. To fly, an aircraft needs something to push it in the opposite direction from gravity. The weight of an object controls how strong the push must be. Lift is the push that lets something move up. It is a force that is the opposite of weight. Everything that flies must have lift. For an aircraft to move upward, it must have more lift than weight. Lift for an airplane comes from its wings. Drag is a force that tries to slow something down. It makes it hard for an object to move. The shape of an object also changes the amount of drag. Narrow surfaces usually have less drag than wide ones. The more air that hits a surface, the more drag it makes. And finally, thrust is the force that is the opposite of drag. Thrust is the push that moves something forward. For an aircraft to keep moving forward, it must have more thrust than drag. A glider does not have thrust. It can only fly until the drag causes it to slow down and land. Wing shapes and sizes of both birds and planes determine how they might perform or what they might be capable of. I'll also take into account the wing aspect ratios, which are high aspect ratio wings and low aspect ratio wings. High aspect ratio wings give a plane more stability, less induced drag, and less fuel consumption. And low aspect ratio wings have a higher fuel consumption, but they are a bit more maneuverable. Now, I'll talk about the variables that will be used in this experiment. The independent variable will be the width of the paper sheet, which will also change the width of the wings. The dependent variable will be the time of flight, and the control variables will be air resistance, the force of the throw, gravity, initial throwing distance, weight, design, and height from where it is launched. Most of the materials used in this experiment are shown in the left image, excluding the paper sheets and the ruler. The design of the paper airplane thrower is shown in the right image. The first step is to build the paper airplane thrower. Then, you'll have to fold the paper sheet into a paper airplane. You'll keep making paper airplanes with different widths, reducing 2 cm each time, until you have 5 paper airplanes. Then, grab a paper airplane and throw it with the paper airplane thrower. You should be recording right before you throw it, maybe with help. Then you'll measure the time it takes to fall, analyzing the video recorded, and you'll repeat the 2 previous steps 5 times for each paper airplane. When you have all your data, you'll register it on a table and make an average of the time of flight. And you'll use your data to make a graph that establishes the relations between the 2 variables. The data collection provided the results shown on this table. As we can see, the wider the wings of the paper airplane were, the higher the flight time average it had. The graph shown is a baseline fit of the relation between the width of the paper sheet and the time of flight. Here we can also see that the values of the time of flight average are bigger when we increase the width of the paper sheet. This is an exponential relation between the width and the time of flight average. After analyzing the results of the experiment, I can say that the hypothesis proposed at the beginning of the experiment was correct, since the paper airplane with the wider wings flew the longest time, and while the width of the wings began to decrease, the flight time decreased as well. And what could have gone better? I think the experiment would have shown better results if I had used bigger values and a bigger difference between them. Also, I should have taken the angle of the throw into account, since my results could have been affected by it. The air resistance was also a variable that I couldn't control as much as I would have liked to, and I probably should have used the branded 9V battery or the adapter to use AA batteries. Finally, these are all the app references for all the websites I visited to realize this project.